Hello, good morning. Today's topic is the fastness property which required in the dye. This part we have covered in the last lecture also. So firstly, we have to overview on this topic. Then we will continue on the next topics. This is the most important question asked on these topics. That's why we are revising this. That is properties, fastness properties which are required in the dyes. So there are four different properties which are required in the dyes, that is a light fastness property, washing fastness property, perspiration fastness property, and heat fastness property. So out of four, first property is the light fastness property. When a dye or printed fabric when a dye or printed fabric is expected to expose in the sunlight, some portion of the light absorbed by the dye molecules. The energy thus absorbed may bring about the self-destruction of the dye molecules. Means what happens whenever we use the dye for the materials which can be exposed to the sunlight, that material should have the properties like light fastness property. Means if the light absorbed by that material and that light can cause the destruction of the dye, so this destruction should be stopped. Means that dye should be heat resistance. Such types of dyes are useful. There are many examples are there in which dyes are used. For example, bikes colors, bike that dye is exposed to the heat, plastics that may be exposed to the heat. We found that many of the chairs in our homes, after exposing to the air and exposing to the light and exposing to the sunlight and heat, the color is changes. As we bring the new chair that having the sharpness colors after 2 years 3 years, and if it is exposed to the light directly, then after 1 month the shade of the colors is slower, faint color is there. Means that there is this self destruction of the dyes. Means colors is not distinguishing properly. Means dyes problem is, so dyes should be such that original qualities that maintain its fastness, maintain its goodness, and last for the long times. This is the quality the dyes should have. Next one is the washing fastness. The dye must possess the good washing fastness. When two or more fabrics are washed together, staining of one fabric with the dye stripped from other fabric will occur. This is the most common observed properties of the dyes. We found that the new color, new cotton shirts, new cotton materials in the first wash loses more and more colors. If that new colored cloths, cotton cloths is washed with another white color cloth, then that colored cloth loses color and white cloth looks like that colors. Means Disintegration, self-disintegrations of that dye occurs at that time. So this is a fastness property. Washing fastness property should have, so that they can be maintained or they can be stick to the colors. They cannot, the color should not be removed from that original one and not affect to the other ones, because in the big families or big industries the washing is done and the collectively more quantity cloths are collectively washed at that time. If any cloth, any cottons loses his colors, that affect to the other also. So this property is most important, that is washing fastness property. The dye must possess good washing fastness. When two or more fabrics are washed together, staining of the one fabric with the dye strip from the other fabric will occur. Third one is the perspiration fastness. Human perspiration can be acidic or the alkaline. Human perspiration can be acidic or alkalinic. Dye must have the stability towards the acidic and basic condition of the sweat, which is called as the fastness toward the perspirations. Depends upon the body temperature and it depends upon the work that man doing. Decide the perspirations. If any person is hard working, doing the hard work in the farm, doing hard work, labor works, at that time continuously body perspiring the sweat and perspiration of oily material from the bodies. That materials firstly stick to the cloths which is near to that body. So that colors, that sweat having the particular pH, sometime acidic, basic, that particular pH changes the dye's colors, changes the dye's color loose. So the dye should be bear that pH sweat and it may maintain the pH. It will maintain its dye's colors and not affect by the any acidic or basic sweats. So it is also most important. That is first perspiration fastness property is most important. So human perspiration can be acidic or alkalinic. It may be acidic or alkalinic, depends on the bodies. The dye must have the stability toward the acidic or basic condition of the sweat, which is called as fastness toward the perspirations. Next is the heat fastness property. Dyes which are applied at a high temperature like reactive dye which are used for the ceramic painting should have the stability toward the high temperature and property is called as fastness toward the heats. Sometimes what happen, we apply the dyes, that material useful for the handling the heating materials. If you are applied to the this dyes to the ceramic material can bear the high temperatures, can bear the high temperatures. But the dye applied to the ceramic material should also have bear the high temperature, because we pour the materials in that hold hot materials or high temperature materials or high temperature applied to the ceramic materials. At that times the dye which is applied to it should bear the temperature. Which loses means it not properly, it not proper, so that it cannot bear the temperature, so that it should be bear the heat. Hence the dyes which are applied at a high temperature like the reactive dye which are used for the ceramic painting should have stability towards the higher temperature and property is called as fastness toward the heats. This is all about the yesterday lectures. This is a revised, we have revised these properties, the important ones. These properties, every dye should possess these properties so that it can become a perfect ones. Next one is the write a note on the important milestone developments. What developments have done and what are the milestones in short, because it is asked for the 2 marks. So there are the milestones. It was research in the organic chemistry, especially in the reactions of the aniline conducted by the famous British chemist William Henry Perkins in the age of the 1838 to 1907, that directly led to the foundation of the modern synthetic dyestuffs industry. He had synthesized and then manufactured for the first time a synthetic dye movie or the movine. The structure is given here for the movine. This is the first time, and this is the first synthetic dyes. This and then onwards continuously developments takes place in the field of the dyes. Now the age there is a lot of continuously developments are going on. Now we are in the apex, means maximum dyes we have developed, means the dyes are like heat temperature all the time there. So these types of dyes we are using day to day lives. But start of this is the from the scientist William Henry Perkins, because he synthesized the first one. Name is the Mauve or Mauveine. Mauveine dye structure is simple structure nitrogen containing compounds having the three conjugations, three double bonds, alkene systems, and having the one nitrogen atom also. This is the 1, 2, 3, 4, 5, 6, 7, 8 membered straight rings. So this is all about the developments have done. First development is there. So in the next lecture we will discuss the next point, that is the chromophores theory and its limitations. So we have discussed about the oxochromes and the chromophores. We have studied the groups like CNO2, CO2, NS2, carbonyl carbon, CN, C triple bond N, CHO, halogen groups. These are all groups of oxochrome and chromophores. But now we are studying the theory of chromophore theory and its limitations. We will discuss its detail in the next lectures. We know that the concept about the if these groups are present on the any structures like C double bond O groups are present, C double bond O CH groups are present, means the aldehyde group present, electron withdrawing group present, electron donating groups present, that definitely affect the um, colors and the visibleness of that colors. Some are the invisible, but after that groups are attached, then there can be easily visible, means colorless to color. The traveling of the chemical from colorless to colors is due to these groups attached to that materials. So we will discuss it in the next lecture. Thank you. Thank you very much.